recording, but we just reviewed what the actual, the position of the extremes and means in a proportion. And if the means have the same value, then they are technically a geometric mean of this relationship. If we're finding the geometric mean for each pair of numbers, we said we're going to set up a proportion. So this is my proportion here. I'm going to put an x in both these spots, B and C. That's where the mean is. Since they told me it's a geometric mean, now I know that those numbers are the same. Those values are the same. So now I can plug in the other two parts of the proportion and solve for x. So we're going to do cross products. I'm always like my variable on the left equals 90. So x squared, x times x is x squared, 6 times 15 is 90. I'm going to let you give the approximate answers for these, but I'm going to review with you how to find the exact answers. In other words, I'm going to review how to simplify a radical. Irrational numbers can only be approximated unless you write them in radical form. And so this particular example, if we take the square root of both sides, now we have x equals the square root of 90. Well, that's not a simplified radical, right? A simplified radical means it can't be any perfect square factors underneath this radical. So I could rewrite this as the square root of 9, which is a perfect square, times the square root of 10. The square root of 9 is what? 3. When do we take your earbud out or earbud out? So the exact answer, the exact mean here is 3 square roots of 10. I am going to let you give me the approximate answer, which means you can just use the calculator. So this is the exact answer, or press 90 and the square root button, and now our geometric mean would be whatever that is. Can someone do it on the calculator and tell me? So is it 90 and then the square root of x button? Did you get it? Is that it, Olivia? 9.5. So it's 9.48, blah, blah, blah. We're going to round to the 10th place. If we approximate, they don't tell us what to do, we're going to give it to the, round it to the nearest 10th place. Unless I tell you differently, I will let you give me the approximate answer. That means just do it on the calculator and round to the nearest 10th place. Alright, see if you guys can write the proportion for this one. They want us to find the geometric mean, and the other pair of numbers for our proportion are 4 and 18. Brandon, you're filling in your proportion, buddy. Do that. So our unknown is the mean. The two given numbers are the extremes, go here. X squared equals 72. I'm only going to do the approximate answer here. I will do another exact answer later, especially if we have time. So now we're going to do 72 square root of x button on our calculator. You guys are not getting calculators each day when you come in and you need to. That reminds me, I am going to take my calculators and lock them up while I'm out, but there'll be calculators up front in that box, or you can use your own calculator. I think there's only 18 calculators in that box, but I know a bunch of you have your own. So I don't care what kind of calculator it is for tomorrow's test, you can use it. Everybody clear? Okay. So what is the square root of 72? Somebody help me out. Tamara? 8.5. Alright, so in example 3, they actually give us the geometric mean and want us to find they give us one of the extremes and want us to find the other number. So if they tell us this is the geometric mean, then 36 goes in both the spots where the means go. The mean, this is the 36 is the mean of this geometric mean of this relationship, and so that value is in the denominator here and the numerator here. 12 is the other given number, and what we don't know is the other extreme. I could put the x there and the 12 there, it does not matter. We're going to cross multiply. it is when you divide by 12. So 108? No. You know you can just hit divide by 108. It is 108? Great. Thank you. So X is 108. Any questions? Jaden?
So you put 36 on both ends?
Yes, because they told us that was the mean,
Okay.
the geometric mean. And so here we were looking for the geometric mean, so our unknown was an X, and it has to be the same, because that's by definition what a geometric mean is. Both those values would be the same. You're good? Now, here, this is where we get into the three similar triangles. So the similarities in triangles, the title of our notes. So in a right triangle with an altitude, so if it's in red, you're underlining it on your notes. If I'm writing it, you're writing it. So an altitude, and that is a segment that goes from one angle perpendicular to the opposite side. It's got to go from the vertex or from the angle to the opposite side. And in this case, you'll see it's going from the right angle. So this big triangle is a right triangle. When we draw the altitude from the right angle to the opposite side, perpendicular to the hypotenuse, so that long side across the right angle is the hypotenuse. And that's going to create two other triangles that are similar to the big triangle. So that means they'll have three congruent angles, and it'll have three proportional sides. So, we have to be able to distinguish what those three triangles are and how to name them with their corresponding parts in the same order. Remember, the order matters, right? So we're going to start, you can name this big, we're going to always start with the big triangle. The other thing is, let's go ahead and underline this here. It will be helpful, especially when you're doing problems where you're solving for missing measures. If your diagram is not positioned this way, to like rotate your paper and kind of get yourself organized with the right angle at the top, and then the hypotenuse at the bottom, okay? I promise you that will help. So if we want to name these similar triangles, where we have to name them with corresponding parts in the same order, we can name the big triangle however you want, and then we're going to use that same order for our other two similar triangles. So triangle DEA, that is the big triangle. Does everybody see that? That is the big triangle here. DEA is the big triangle. When we named it DEA, it's going to help us to remember where we started in our path around, right? So when we named it triangle DEA, remember it could be named triangle EDA, it could be named triangle AED. But since we picked triangle DEA here, now we have to name the other two triangles in the same order. So it helps for you to look at what is the path you took. So here we started at D, and that is at the right angle. So that is the right angle, the big triangle. Then we moved down the short side of the triangle, the short leg, to angle E. And then from there, that angle, we went down the hypotenuse to A. Okay? Does that make sense? So short leg, then the hypotenuse. We started the right angle, went short leg, then hypotenuse. So now let's look at this little triangle here. So let's look at this little triangle. I'm going to outline it in green. You don't have to outline it if you don't want to. It doesn't get kind of messy on yours. I can erase mine. But now we're going to name this the smaller right triangle that was formed by this altitude. So here I started with the right angle. So now I need to start with the right angle of this triangle. So I need to start with the right angle of this triangle. So the right angle goes here. Now here I went down the short leg. So if I start the right triangle, this is the short leg, this is the hypotenuse. Now I'm going to start at H and go to the short leg. Then I'm going to go from there down the hypotenuse. So when I name that one, it's going to be triangle HE to D. Does that make sense? We started the right triangle, we went down the short leg, and then down across the hypotenuse. So now we're going to look at this left triangle that's created by the altitude. So it's created with these three angles, D, A, and H. We're going to name them the same way as we just named these others. So this triangle, A, and it's got these three vertices. I made it a little bit messy, but you get the gist. If this is a right angle, remember this is the right angle of this triangle. So right angle, right angle. So what are we going to start with here? What angle are we going to start with here? What do you think, Ethan? What's the letter we're going to put first? What'd you say? Yes, so H is the right angle on this triangle. It's the right angle in this little triangle, and it's the right angle there. So H. So now here we went from the right angle, down the short side, and then across the hypotenuse. So what's going to be my next letter here? What's going to be, Kamara? So we're going to go from H to D. Very good. And then from D, down the hypotenuse. Perfect. All right, so now we're going to name the big triangle differently. We're going to do it, there's at least 3 ways to do it, or there is 3 ways to do it. We're only going to do 2, but we're going to start with naming the big triangle now, EDA. Don't forget the triangle symbol. So triangle EDA. So in this case, we start with the angle where the hypotenuse and the short leg meets. And then we go down the short side, and then we go down the long side. The short leg, then the long leg, right? So if it's EDA here, we're going to do this little triangle next. So the angle we started at was the angle in between the short leg and the hypotenuse. So if we're going here, what is that going to be? So what is the angle between the short leg and the hypotenuse on this triangle? It's going to be E, right? Short leg and the hypotenuse. Very good. So E, H. Oh, wait a second. Yes. We went EDA. And we're going to do EHD. So we went down both legs, short leg, then long leg. And here we went short leg, then long leg. So what's going to be the first angle in this triangle? What's going to be the second one? D, then H. So we went down the short side, then down the long side. So short leg, then the long leg. Does that make sense, Max? It's not hard. You do have to make sure you're following the same kind of path when you're naming them. Does that make sense, Rebecca? Okay. You caught up with me? Alright, now, there's a special relationship between the geometric mean, and there are actually 3 geometric means in triangles. So here, everything we're going to learn has to do with a big right triangle that we've drawn an altitude, and we've created 2 other right triangles, 2 other similar triangles. So we have these 3 similar triangles that are formed, and the geometric mean is the length of the long leg of the big triangle, the short leg of the big triangle, and the altitude that we've drawn to create the other 2. So those values are all are all the geometric mean. They represent a particular relationship between the length of the long leg to the different parts of these 3 triangles. The length of the short leg to the different parts of these triangles. the length of the altitude to the different parts of these triangles. So D, B, and E are the legs and altitude of the big triangle. When Miss Rayleigh teaches it, she calls them floaters because they're up higher than the other letters on this diagram. I'm going to try to make it bigger. When I make my whole screen bigger, it goes off the screen. So I didn't know that when I first did it. There you go. So the first part we're writing is that D, B, and E are the legs and altitude of the big triangle, and you can kind of call those floaters. You can kind of see that they're up in the air on this triangle, especially if you turn that triangle where the right angle is at the top and the hypotenuse is at the bottom. So these are the geometric means of this relationship. So if we're going to use a proportion, D, B, and E are the geometric means. D, B, and E are the geometric means. And we know, we just learned that the geometric means in a proportion are always equal. So the value in the proportion would be the same. So they will always repeat in the proportion. Extremes are the parts that they touch. So D, B, and E are the geometric means. There's 3 geometric means. All the parts of the big triangle, well, the 2 legs of the big triangle and the altitude that we draw to create the other 2 triangles, those are the geometric means. So when we use those values to find missing measures in a figure like this, then those would go in the mean spot and they repeat. So AC and actually F, which is the sum of AC, and that's the hypotenuse of the big triangle, you'll see. So from X to Z is the hypotenuse of the big right triangle. That is one of the extremes. And then they split that hypotenuse into 2 segments. That would be the legs of the other triangles. John Luke, sit up, pencil in hand. So A, C, and F are extremes. That means they're going to go in these spots. The means are always going to go in these spots. To be clear, this is another diagram for F. So F, if A were not 9, C is 14, then F would be 13. So just to clarify, F is the whole length of the hypotenuse. Not right now when we're done. If there's enough time when we're done, you can. But got to be 10 minutes left. We've got to finish this first. All right, if you didn't sketch that really quickly. It'll take you about 10 seconds. All right, so now we can give ourselves basically 3 formulas to use when we're finding missing measures with a figure like this. 3 similar triangles created from one big one. So we're going to always start with our geometric mean. In this case, that's D. Remember, D, B, and E is a geometric mean. They always go bottom left, top left. So the extremes for this proportion are going to be this part of the hypotenuse that D touches, but it's also going to be that whole length of the hypotenuse, and that would be the A plus the C. We could call it F, but we're going to be more descriptive. So A plus C. Now the relationship for the geometric mean, that's the length of the other leg of the right triangle. Remember, bottom left, top right. So E, right here, the length of the short leg, its extremes are this part of the hypotenuse that this side touches, right here, C, and also that whole length of the hypotenuse, or A plus C. Yeah, do not write what I'm writing, baby. I'm watching you. You're coloring. All right, and the last one, I already put B in here. B is the altitude, but that is also the third geometric mean in this relationship of all these triangles, similar triangles, right? So this one is a little bit different. So I gave you the mean here. So for this geometric mean, we use this part of the hypotenuse and this part of the hypotenuse. We do not use the sum for this proportion. So these are formulas that you're going to be able to use to solve for missing measures in these kind of figures. You guys caught up with me? All right. So we're going to start with example 4. And we need to be able to find W, X, and Y. In example 4, there's only a W. So in that diagram, which of those expressions is the geometric mean? Which of those expressions is the geometric mean? Caleb, do you know? Which one of those expressions is the geometric mean? In example 4. Sorry? Yes. So W, remember, so it's the length here, the altitude, the length of the altitude in here. So W is the geometric mean, so we're going to use a proportion. W is what we're solving for. It's the geometric mean, so it's got to go in the geometric mean spots. Now this is the one we don't use the sum. We use 6 and 4. We use the parts of the hypotenuse. So it's W squared equals 24. So we take the square root of both sides. So on our calculator, if we're taking the square root of 24, we enter 24 in the square root of X button. We're going to get 4.89. It continues on, but we're going to round to the 10th place. So if we approximate this, we're going to round to the 10th place, so we approximate that at 4.9. If I wrote it as an exact answer, it would be 2 square roots of 6. Right? All right. Example 5. What is the geometric mean that they've given us? The expression that represents the geometric mean, Zyla. Example 5. Which one of these expressions is the geometric mean? Yes, very good. So that's one of those floaters, one of those upper expressions. So that goes in the mean spots. Now this one, let's look back at your notes. Hopefully. So this one is in this spot, right? So E, and it's the sum of A and C, and that's the length of the hypotenuse, and C, that part that it touches. So here, X touches DB, which has a length of 4, and we use the length of the hypotenuse, which is there, but that doesn't matter. So now our proportion simplifies to 4 over x equals x over 10. We're going to cross multiply, and x squared equals 40. Take the square root of both sides. And the approximate answer here, if we round to the 10th place, is 6.3. We have to take the square root of both sides. That's how we get x. And these are lengths. The geometric mean represents a length. These other values represent lengths of these parts of these triangles, so we only use the positive solution. All right, what's my proportion? So you guys try this one. Try example 6. Where do you put that y? Where do you put the 6? Or do you put the 6? Do you put the 4? Do you put the 6 plus 4? What do you put? So which one of those is the geometric mean? You're going to put that in the bottom left and the top right. Put the geometric mean in the bottom left and the top right. 6 and 4. 6 and 4 are not the mean. Nope. Tamara? Why? Remember, the mean is here, here, and here. They always are across the top here. So y goes in the geometric mean spot. What goes in the top left and bottom right? Kamara knows. You know, Max?
6 plus 4.
6 plus 4 goes in one. What goes in the other?
6.
Good. Is that what you were going to say, Kamara? Nice. So now we're going to cross multiply. And we're going to take the square root of 60. And we're going to round that to 7.7, I think. Yep, 7.7. Any questions? The next two examples, you're going to have to find multiple different links, multiple different missing measures of these figures. So the trick is, looking at example 7, the directions say find w, x, and y. Remember those represent lengths. Looking for our means first. This is what a mean, and this is a mean. There's another mean here, but they don't give us the measure of that, so we can't use that one, right? One of the hints I would give you, or tips, is if they give you a numerical value for the mean, one of the means, start with that one if you're finding multiple missing measures. So here, that's a mean. We're going to go ahead and plug it into the mean spot. Now this is one that we use the entire length of the hypotenuse and the side it touches, right? So it touches this part of the hypotenuse that is w, and then we use that w plus y, which in this case they give us is 36. Does that make sense? So now we're going to cross multiply. 36w equals 324. And we're going to solve for w, divide by 36. And so now we know that w is 9. So now we can say that w is 9. Well, now, can anybody tell me how to find y? Now that I know what w is, I know what the whole length is. How can I find what y is? What do you think, Kamara? Yep, 36, the whole length minus that one. So y is 36 minus 9, or 27. So we found w, we found y, it's 27. Now we've got to find x. So that floater, well, first off, let's go ahead and write a proportion. So the proportion we're going to use, x is going to go in the mean spot, because that's one of the ones up here, that's the mean. And remember, this is one of the ones that, you use the segment of the hypotenuse that it touches, and then the whole length of the hypotenuse. So here, it touches DB, which is 27, and the entire length of the hypotenuse, which they've already told us is 36. So now we cross multiply. 27 times 36. Thank you, 972. And take the square root of both sides. And we get x is 31.17 something. We're going to round to the 10th place. 31.7. Remember, this is an approximation. If you want an exact answer, you got to simplify that radical, the square root of 972. So x, y, and w. We actually have enough time. Let's give the exact answer for this one, just so you have one other example. So x is equal to the square root of 972. Perfect square, that'll come out of 972. Let's see. Actually, we already know a perfect square because 36 is a perfect square, right? So we can start with that. So the square root of 36 times the square root of 27 equals the square root of 972. So this simplifies to 6. So now we have 6 square roots of 27. But remember, this is not simplified if there's another perfect square factor under there. So I'm going to need to simplify it some more. So that'd be 6 times the square root of 9 times the square root of 3. And so that would be 3. So 6 times 3 is 18 square roots of 3. So this is the exact answer, which you do not have to give unless I tell you you have to, or the directions ask you specifically for the exact answer. On the test, if it asks for the exact answer and you don't know how to do this, you can give the approximate. You won't get full credit, but you'll get most of the points. Right, but you should be able to simplify radical. This is stuff that you learned about in algebra. All right, and the last example, very similar to this one. What are the means? Which expressions represent the means in this figure? Jaden? Perfect. It's floating in the air. The one that we have a numerical value for is a 12, so I'm going to use that one first. Because that gives me two numbers, my proportion, right off the bat. So I know this is the altitude mean. So if I go back over here, remind myself, oh, okay, B, that's the same one. I don't use the whole hypotenuse here. I use the two parts. This part of the hypotenuse and this part of the hypotenuse. So that's what I'm going to use. I'm going to use 24 and W. Remember, I could put W and 24. That doesn't matter. So cross products, cross multiply. 24W equals 144. I'm going to divide both sides by 24, and I think that's 6. I walked away from my calculator. Yes, thank you. So now up here in my diagram, I'm going to replace W with 6. I know what W is now. So now I've got to find my Y and my X. It does not matter which one I pick. I'm going to start with the Y just because it's on the left. Let's go ahead and fill that in. See if you can fill in without me. I'm going to give you a head start. Give you about 15 seconds. Fill in the 4 parts of the proportion. Where does the extreme go? The mean go. It goes in the bottom left and top right. Remember, the mean is the expression that's floating, and we are We are solving for y now. So y and y. So when you have, the mean that represents that is the length of one of the legs, you use the part of the hypotenuse it touches and the whole hypotenuse. In this case, the whole hypotenuse is 24 plus 6, or 30. So it's going to be the whole hypotenuse and the side that it touches, which is 24. Is that what you guys got? All right, we're going to cross multiply. And we are just going to give the approximate answer here. So that's y squared equals 720. I'm going to take the square root of 720 by hitting the square root of x button. It's 26.832, blah, blah, blah. We're going to round to the 10th place. 26.8. See if you can set up the last proportion. We need to solve for x. We need to solve for x. So what's going to go in that proportion, Brandon? You're going to be writing your next proportion. Where does the x go? Good. Now what goes in the top left, bottom right? Remember, it doesn't matter which one you put where, but the same two numbers. So if this is x, which two numbers are we going to use? Wendy, do you know? No. Kyron, do you know? 30 and 6, yes. So this is the one we're solving for. The segment of the hypotenuse that it touches is 6, and then we use the whole length of the hypotenuse. So it's going to be x and 30 and 6. So multiply, x squared equals 180, and we're going to take the square root of 180. 13.416, blah, 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 keeps going. We're around to the 10th place. So x equals 13.1. We want to give the exact, yes? Oh, my bad, it is 13.4. If we wanted to give the exact answer, square root of 180, just so you have one last example. I'm going to write this in the perfect square factor that I know first. The square root of 9 times the square root of 20. It's going to simplify to 3 square roots of 20. But now that I look at it, I see that the 20 also has a perfect square in it. What's the perfect square factor in 20? What? 4, yep. So that's going to be equal to 3 times the square root of 4 times the square root of 5. And the square root of 4 is 2, so that's going to be 6 square roots of 5. And I'm just giving you a quick review on that. I think we are going to cover that a little bit more detail later, but that is algebra. You should be able to do that already. So, any questions for me? So this assignment is not due tomorrow. This content is not on your test that we're taking tomorrow.